Welcome back to another YouTube Tuesday. My name is Derek, and today we're going to be watching a YouTube video from the YouTube channel iBoard Repair by Aaron Harrington. And after we go over it, I'm positive you'll see why I've chosen to react to this video. So let's get started. Now the video that we're going to be watching is almost 6 hours long, so I'm not going to be reacting to all of it. I will be cutting down this video from 6 hours to something much shorter than that, but I highly recommend you check out his channel. The title of this video is When I Charge $2,000 for Data Recovery, iPhone 15 Pro RAM plus CPU swap. So without further ado, let's get started.
Hi, this is Aaron with iBoard Repair, and today I'll be recovering data from an iPhone 15 Pro that suffered a very severe smash. I believe this was run over by a car. And on this motherboard, what I'm seeing is a RAM short, which, if you don't know, the RAM is soldered to the top of the CPU, and this is essentially the hardest type of data recovery that we could possibly see. So let me show you what I'm working with so far. So this phone has gone to a couple of shops before it got to me, and they already did a little bit of work. They took off the screen, and they've already even separated this bottom motherboard away from the top one. Here's the top motherboard, and this is the one we're going to be focusing on. It's the important one where most of the data chips are stored. All of them, actually. This is the NAND, this is the EEPROM, and this is the CPU. The CPU has a layer at the very bottom, which is the actual CPU, and most of this package is actually the RAM. And the RAM...
So for those of you that aren't aware of those three components that he was talking about, if you were able to transfer those over to a good board, you can recover the data. Say the board snapped and those three components weren't damaged, but the board is non-functional. If you transfer those over successfully, you'll be able to recover the data. In this case, he has that situation, but is also running into a RAM short. The RAM has always been difficult to replace, but on older models it's much easier. Because of the way that it was soldered on, like say for an iPhone 6, a lot easier to remove the RAM off the top of the CPU and replace it if there was an issue with RAM. On these newer models, however, it's not the same story, and you'll see what I mean.
RAM is where we're seeing a problem on this phone. The last technician looked like they were about to attempt a CPU swap before they figured out that that's not going to solve this issue. And they also determined this was most likely a RAM problem before they contacted me. And let me show you how I figured out that this actually is RAM. So the first thing I like to do when I'm working with a phone that is giving me no power is I'll take my DC power supply probes and I will touch them to the battery connector, and I'll prompt this phone to boot, and I will observe the amperage draw I get when I do that. In this case, there's no amperage draw before prompt to boot. That 0.002 is normal for my DC power supply. And if I prompt this phone to boot by shorting the power button line, it spikes up here, and it will just sit at this this high amperage draw. It shouldn't be at 0.3 yet. It should be at like 0.06, and then we'll move to 0.2, and then it will eventually start moving up, but it shouldn't go straight to this 0.36. So that will tell me that I have a short on the motherboard. And what the last tech did, he showed me a picture of what he was working on. He used his thermal camera, and he just prompted the phone to boot, and he followed where the heat was going, and he was able to see what looked like the RAM heating up. So that's how he determined it was most likely RAM. And I'll kind of show you if you can see my thermal camera here. So I have my thermal camera here, and I have the CPU in frame. And it won't be the clearest view for you, but you should be able to see the spike in heat. And we can see pretty instantly this box is heating up. If I move around, there's not much heat elsewhere. And that box is, like a part of the RAM module. And that's what the last tech was able to determine as the cause of the short. I was hoping for a bit more concrete evidence than just heat, because the heat can be misleading sometimes. So I went ahead and I started measuring all the power rails around the PMIC, and especially the RAM power rails. And I had my 1v8 RAM power rail right here, and that's giving me a normal reading. I had my OV6 power rail right there, and that's giving me a normal reading. And my 1v1 power rail right here. If I didn't already suspect RAM, then this may come off as a normal reading. The 0.02 isn't that far off of what a normal reading should be. I think it should probably be 0.04, 0.05, but the 0.02 is not full short. And I guess right now is probably a good time to compare that to like a donor board and see what that's showing, if I have one. And I do. I have one here that has the NAND off of the board. And if I compare the diode mode reading, I'm not quite sure what it should be. Let's see. 0.01, it's even less. So that's interesting. I don't know if this board is actually booting, but let me just see this while we have it here. And it won't fully boot with a NAND off the board, but it should give me some amperage draw that shows it's close to booting. And yeah, this is giving me like a brain dead amperage draw, which is normal. So this should have my power rails turning on. So if I were to check the voltage on these lines on my donor board, they should all be correct. So let's see if that's true or not. Here's my 1v8 up here. I'm getting 1.8 there. See if we can get access to the OV. This is OV5, not OV6. I forgot that they changed it on this model, so I should have 0.5 on here. 0.5. And then my 1v1 line should be 1v1, or 1.1. 1.05 is perfectly fine. In fact, that's in other models that's called a 1v06 line, so it's definitely perfectly fine. If I do that same test on the board that I'm working with, if I give it power and check these lines, so we have the 1v8 line up here, and we do in fact get 1.8, and my OV5 line down here, I do get 0.5, and my 1v1 line right here, I'm only getting 0.88. And that was the first bit of proof that I saw that I actually do have a RAM problem here. The next thing I checked was what will happen if I set my voltage to 1.1 and I touch that line. Before I do that, let's say I set my voltage to 1.8 and I touch the 1.8 voltage line. What do you think will happen? Basically nothing will happen. I will get no amperage draw. If I touch ground, it will give me a full amperage draw like that. If I touch the 1.8 side, it should be almost nothing. I do get that 0.03. If I do that on my good board, I wonder if I will also get 0.03 or if I will get nothing. 0.03. So that's normal enough.
So obviously what he's doing is he's comparing against what he hopes is a known good board. And he's been doing diode readings, and he's also been reading the voltages. Now, the way to read a voltage is you inject power. He's got a cable that he's got connected up to the motherboard so that it's constantly putting in power so that you can actually check what the different lines are reading. Versus diode mode where you don't want power connected, where you're testing the continuity between lines to see if there's a short, to see what you're getting, and you're comparing and contrasting that with either a schematic board view software or a donor board. And obviously he's got access to a schematic, otherwise he wouldn't have really be able to narrow down those lines without it, and therefore he can then compare that to either the readings that the schematic or diode board that the schematic has, or the board view, and then cross-check that with a hopefully good motherboard. So we'll skip a little bit further in the video here, but it shows you what it can take to diagnose an issue like this. It's quite involved. The issue with this particular type of RAM is the way that it's installed. The best way to remove this RAM, at least from my experience, is to at least start with a grinding tool. Now there are some CNC style ones where you basically set the motherboard up in a jig, you zero out the CNC so that it knows the depth it needs to cut, and it'll run a pattern and it'll actually cut out or remove layers of the RAM off the top of the CPU incrementally until you get down to the pads. The other way to do it, which is more manual, which is the way that he's going to show it here, is to remove it with the assistance of a blade. So let's get a little bit of a view of what that looks like.
A little bit of time. It is probably time for me to start doing this with a CNC, but I don't have one, and this doesn't take me too long. I really like that first cut, actually. That's looks like it's going to break away pretty easily in this case. And right there's the depth that I'm looking for.
So as you can tell, he's using that knife really with a lot of skill and precision. He's obviously done this before. It's something where you definitely want to practice multiple times on a donor board before you actually try to do it on a customer board, because if you go just a little too deep, you ruin the CPU, and there's really no coming back from that. There's no recovering the data at that point. Using a mix between a CNC, getting down to nearly the perfect level, and then going in with a blade to kind of clean up the surface is probably the best technique I'd say you can find. So I bet you at some point he'll invest in a CNC and be able to improve his ability to clean up the RAM and go from there. You can see how at a certain point he's comfortable enough to kind of go at it nice and hard, but this is definitely a job where you really have to be fully aware of every single step that you're taking. Luckily, the CPU itself is to a certain degree flexible, but it also has the reinforcement at this point with the underfill, the solder balls below it to help it not bend too much so you're not putting too much pressure on it and breaking it. But you really have to be careful if you're going to go about it in this way. It also shows you what's possible, because this isn't something that is practical for a lot of techs. Alright, so we're into the video about 40 minutes, or 50 minutes, and you can see that he's semi-cleaning the top of the CPU. He's got the RAM basically fully removed, and he's just cleaning up some of the layers that might be just coating the top of the CPU itself.
Okay, I am getting there. Just a little bit more cleaning, and then I'll do a little bit of testing before I come back and just completely flatten this all the way. I can make it good enough right now that I can make sure that it's like my voltage should be normal on my 1v1 line at this point. My amperage draw when I prompt to boot should be a looping like 0.12 or something like that. A looping amperage draw, and I should be able to force it into DFU mode still. So if all those things are still true, then everything is going according to plan.
The ability to kind of feel where you're scraping is what it comes down to. I mean, there's the visual as well, where you can see the layers, but you can actually feel them through the blade more than you can really see them. So let's jump a little bit further ahead to see where his next step goes. Because at this point you really want to be checking to see what voltage you have to the RAM. Because if that's low, then you might have another issue with, say, the PMIC.
So this is just not correct. I can't really just remove RAM on a donor board. I mean, I could, but that's a whole lot of work to see if this is like normal behavior with RAM off. That's not what other models would do, so I don't expect it would be normal behavior. I do see there's like a really tiny crack in this coil next to my line. So I want to see if this is possibly loose. If it was, though, I wouldn't expect the voltage I have on it to be what it is. I'd expect it to be basically 0. So I'm just really thrown off by the fact that that didn't change to a good voltage. Also, I don't know if this model should behave differently upon prompt to boot with RAM off the board. I know that on other models I should have a boot looping current draw. And on this model I have a steady current draw. And that's just another like uncertainty I have with this, because I wouldn't really expect that. I mean, it may have changed, I just don't know. And it's not really following the pattern of previous models. It doesn't really appear to me that this is loose. If it was, I think it would have already came loose. So my 1v1 line is not good. I mean, it's not the correct voltage. It also doesn't take any amperage if I touch it with 1.1. So it's not short. The 1v1 line is an output at the PMIC. So I guess PMIC must be damaged as well. I mean, that's really the only thing I can think of with this. And I think I'm just going to have to replace the PMIC. I think that's going to be my best course of action, because I can't really justify moving forward if my voltage is not correct on that line. Because I don't expect the line will work if my voltage is incorrect on that line. Schematics say that line can handle 2.5 amps. So I know I had like a kind of a high amperage draw when I first touched it with the voltage. That only got to like 1.8 amps, so that shouldn't have been a problem either. So I don't know why this line is not giving me normal voltage on that line. And if I replace PMIC and it's still the same, I'll at least know I ruled that out. And if it's fixed, then I could just move forward.
Alright, so for those of you that haven't seen how to remove a PMIC and replace it, I have videos showing how to do that. There's also plenty of content on there. Let's skip a little bit further ahead in the video. One of the things you can see though is he's actually labeled different chapters of the video. So right here he's got removing the PMIC, then harvesting the donor PMIC, soldering the new PMIC, and then finding that the RAM is still low again. The voltage for the line to the RAM is still low, and then comparing the voltage of donor board that has the RAM off, and he's going to flatten out the top of the CPU before removing the CPU. So let's take a look at that real quick. So here he's removing the last layers, basically the adhesive layer that held the RAM to the CPU. And there is the visual part of it, but it's really by feel. You can feel when it's skidding across the top of the CPU, and when you're kind of digging into the last layer of like resin that was holding it down. In some previous models, you didn't have that type of thing. It would split apart in a much easier way. I mean, they still always had some amount of like almost like an underfill between them, but you could slide a blade like that you would like under a CPU. You could slide it in between the RAM and the CPU and pop them apart. Let's skip to him now removing the CPU, which you have to be a little bit more gentle with it because you've now taken away a good portion of its mass. You've removed the RAM, which helps keep it rigid, so you have to be careful in removing the CPU at this point.
I think I'm going to want to move some of these out of the way just to make it as easy as possible to get underneath.
That was perfect. You could see that the majority of the underfill actually stayed behind on the board. He's definitely not going to be reusing this board. It's got way too much damage. Maybe he'll use it for some parts if he needs to find a specific coil, capacitor, or an IC for future, but it's another step where things, if they go wrong, the data is gone, unfortunately. So looks like he removed it perfectly. The title of the next chapter is Removing the Donor Board CPU and Cleaning the Pads. It looks like that board already had the RAM removed from it, so he's probably going to have to salvage the RAM from even another CPU, but he's removed it. He's cleaning up the pads. You have to remove all of the underfill and carefully go about prepping it. Basically, you're going to be adding a low melt to mix with the factory solder to really help wick it so that you're not pulling pads. You also need to remove all of the underfill, especially around the border, so that you can actually solder down the CPU when the time comes. This is a very time-consuming repair, and everything he's been doing up to this point, we're 2 hours into the video, it's all very time-consuming. But when it comes down to saving the customer's data and also earning the $2,000, it is worth it. So you can see he's wicking up the solder, taking his time to carefully get all the edges. He's going to be removing the donor board NAND as well, because you need to pull the NAND off the original, otherwise you don't have the data, because that's where the data is actually stored. But you need the CPU to access it along with the EEPROM to bridge the two together. So he's removing the donor board EEPROM as well, and then he's cleaning and reballing the CPU. Let's take a look at that. So before we hit play, I can see that he's got a decent ball of solder on the end of it. He's got probably a low melt, and he's going around really sucking up all of the factory solder into that larger ball of solder. This will allow him to basically get it to the point where he can wick it without stress. And one of the things you'll notice that he was doing was he was only letting the actual solder ball itself touch. He wasn't actually letting the iron touch the CPU at all. You risk potentially scratching it anytime you interact with it. And if you scratch things, you can pull pads, you can dig into the ground layers, you can create shorts. But he's doing everything he possibly can to not actually touch the surface, which is actually quite nice. And he's salvaging or leaving intact the capacitors that a lot of people will just swipe off, because for data recovery you really don't need them, but he's leaving them on, which I actually appreciate. That's what I like to do if I can do it.
And I don't have a RAM for this chip yet. I will have to harvest one, but you know, this video is just getting longer and longer, like I don't even know, but I will put the iPhone 14 RAM in place here, just so I can get this chip to sit at the proper level. As you can see, this is like a little bit skinnier than that chip, but up here it will sit at the proper height now, so the stencil is pressing down properly. I didn't notice before, but I do have another missing pad here, and I don't know what that one is, but it's probably a CPU power rail or something like that, so I think I'm just gonna mask that off just in case. I don't want anything to short to ground on accident.
Alright, so depending on the line that's died on, or that's pulled on the CPU, sometimes you actually need to go back and put a new pad there. It's quite complicated to fix pads on the CPU side of things, because you have to deal with kind of a large cross hatching of ground plane. If you're very careful and you have a really sharp scalpel, you can actually remove that grounding layer around the area where the pad is, find the trace that was tied into that pad, and run the jumper to it without grounding out the jumper. Roll that jumper wire up to create kind of a pad, cure it with UV mask, scrape away the top, and now you have a rebuilt pad that isn't going to potentially short to ground. It is very complex. I wonder if he verified what line that was to see if it really wasn't important. The CPU does a lot of work, but in order to get it to boot and access the data, you don't need every single line. So that's probably why I didn't risk it and just covered it up. Now he's reballing it, got some solder paste on there in the stencil. Let's see if he has any tips and tricks to show us how he does it. So he's not really talking about what he's doing, but what he's doing is he's evenly heating up the stencil. If you heat it up too much in one spot, it will warp like crazy, and when it warps, you getting it to be reballed perfectly when it warps is like game over. But if you heat it up all uniformly, it won't warp as much. You won't have to hold it down so hard with tweezers, and you'll be able to get it to reball. He's obviously comfortable coming in from one side and moving towards the middle and then switching around going to the other side instead of trying to go all the way across. Maybe he's found that he has more success reballing his CPU doing that. This is one of those things that just kind of comes with experience and finding out what works best for you. Now I have this special pair of tweezers. You can see it's got the two kind of flat sides there. Really helps when you're pressing down on the CPU to be able to not have it kind of warp as much, because you're keeping equal pressure across a larger area instead of just having the tweezers kind of try to kind of push evenly. It's quite difficult to push down on the entire stencil with tweezers that are just straight like this. Alright, so he's reballing the CPU. We'll skip a little further ahead. Now he's soldering that CPU that he's reballed on top of the donor board. You need to make sure that this is in the proper orientation, but luckily those capacitors make it really easy to see where it's going to mirror, so that when you flip it over, you didn't get it the wrong way around. When the CPU settles, you're going to actually see kind of almost like a flood of flux come out from under it. You'll be able to kind of tap it, nudge it, get it to snap back into place. There's a few different techniques that you can use. You really want to make sure it doesn't. You really want to make sure that it goes down properly.
Alright, that should be on there. I'll wait for this to cool, clean it up a bit, and then we can test the 1v1 voltage and see if it's back to normal or if it's still staying at the 0.89. Reball looks pretty good. So my diode mode measurement on my 1v1 line should be back to like that 0.02 or 0.04 or something like that. Let's see what it is. Oh, sorry. It shouldn't be. 0.49 is still normal because RAM's not on the board. I don't know why I said that.
So now he's found that the RAM is finally kind of normal. He's got to clean up the pads for the donor, for where the NAND goes on the donor board that he has. Then he's going to remove the NAND and reball it. Let's take a look at the NAND removal real quick.
As you can see, like the actual footprint is the same. The chip is just bigger.
Alright, so let's blast through the rest of this video, as we're quite a ways into it ourselves. We've actually made it basically halfway through his video, and I think we're going to be ending here in a few minutes on ours. So from here, he cleans up the NAND, reballs it. You have to solve over the EEPROM, which is basically a smaller version of what we've been doing so far. if something goes wrong with the EEPROM, it's game over, and it has to be that EEPROM. Now he's going to have to find another CPU that he can take off the board and remove the CPU portion to salvage the NAND. And this is quite complex, very similar to removing the RAM off top of the CPU, except you flip it over and do that same thing in reverse. So let's get a quick look at that, and then we'll move on. You can see he's digging through the RAM side, or he's digging through the CPU side, getting down to that same layer of pads for the RAM itself. And you can kind of see as I drag across this bottom portion that this take goes from around 3 hours and 15 minutes all the way up to 4 hours and 15 minutes. So it takes him a full hour to remove the CPU the manual way from the RAM. Of course, having a CNC would cut that time down substantially, probably from an hour down to about 10-15 minutes, which is a substantial savings in time. And this is where you do need to have, or not necessarily, but you should have a stencil. If you don't have a stencil to reball the RAM, it is totally possible to reball it manually. It just would take forever. So he's tinning the RAM pads. The next section is called Reballing RAM without proper stencil, which means he might be able to reball portions of it with a stencil, but he's going to have to add manually a lot of these solder balls. So looks like that's what he's doing. He's actually making a bunch of solder balls and then adding them one at a time around the border. That is tedious work, but shows you what's doable. Okay, and then evening out the RAM solder balls. Now he's got a really cool technique that I've actually never used before, and I'm excited to use it. I always just use the stencil when I have one to flatten out the pads, but what he's doing here, and he explains it a little bit better, is he actually takes just a regular white piece of paper, and he'll take the solder balls and put them face down on it, and just kind of massage it around in circles, and that'll actually shave off layers of the solder, taking the solder balls that are bigger, shaving down some of them so that when you reflow it again, they're all more equal in size. And he'll do that a couple times until there is uniformity across the solder balls. You can get the same thing with a stencil, where you scrape off the top with a blade and reflow it and continue to play with it if you need to get them uniform. But it looks like he then flattens out the top of the CPU. He's basically removed all of the last remnants of the old adhesive that was holding the RAM to that CPU, cleaning up the border. You really need this to sit nice and flat and perfect. So let's see, preparing the top CPU pads. Okay, there's almost like the solder pads themselves on top of the CPU are almost like inside of a hole, and so by filling that top layer with some solder paste, you can actually prep them or tin them so that you will have a much easier time soldering the RAM on top of it. And so it looks like he's adding solder paste to it. We can kind of get a look at what that looks like, and we're at kind of close to the end of the video here, but you can see he's smeared in solder paste into those little portions.
Well, I can't believe that, but I just missed the most important part. I just set this on here. I'm not quite sure where I paused the video. I'll stop and see. Yeah, so really dumb of me. This is like the culmination of the whole video was me setting this RAM onto the board, but I didn't actually record that. It was very, very simple. All I did was place it onto here and then heat it up, and now I'm waiting for it to cool back down. I did mention how nervous I was, just because this is a culmination of a lot of work, and I'm really hoping it will go the first try. This is probably almost about cool now, and we can take a look to see how it looks, and then I'll be measuring the SD-RAM lines to see if they went short or not. I mean, I don't think anyone would ever think I'm faking it, but but if you did want to like double check, you can see that these two capacitors had these marks on the end of them for the whole video. I really don't, it was really hard to reball this chip, so if this doesn't go the first try, there's a few things I can try to do, but I may end up having to just wait and order the proper stencil. Let's take a look at see how it looks. I really hope I don't see any shorts. Honestly, that looks beautiful. That's one of my best placements. You can still see the CPU balls, you can see the RAM balls.
Alright, and towards the end.
I don't know how long this video is or how much footage I have, but if this is booting, basically nothing went wrong. Everything just takes this long. It's just so many steps. I didn't have the stencil, which really slowed things down, and I didn't have a harvested RAM, which slowed things down. I didn't have a prepared CPU board. We have an Apple logo. This is beautiful. Oh my goodness, I'm very happy. Just make sure it gets all the way to boot. Then I have to grab the jig and make sure it fits. Long Apple logo. What is that? I honestly don't know what this could indicate if I get this far and it's getting stuck on the Apple logo. Obviously, I'll probably have to try a update to see what's going on. Maybe it just needs an update. But if it's getting to the stage where it's showing an Apple logo that's like so far along the boot process, it's basically done. Unless I have like data corruption. The NAND chip, I used a lot of heat to remove it. It was like very stuck on there. The underfill was kind of hard. It's possible something went wrong there. But let's just put this in the jig and try an update, because this is going to be heartbreaking if it doesn't go. Okay, it's in there. I'll go ahead and attach the proximity sensor and also the wireless charging coil for this one. Jesus, my hands are shaky from all of this work. Still have an Apple logo. Let's just wait one time first again and see if it doesn't.
Alright, so he's put it in a jig. He's connecting up everything that you would potentially want to connect to it to have the phone turn on, not boot loop, things like that. It may need an update, so let's see what he goes from here. But basically, to get it to the point where you get an Apple logo again, means you've done at least something right.
The only way I can really get this one into recovery mode is if I hold the power button either while it's rebooting or while I boot it up. I have to plug in the battery at the same time that I hold this power button, or that I short the power button. Plug in the charge port. Okay, it's in recovery mode. Let's plug it into my main computer. Okay, let's give this an update, see what it does. That was a very long update. It stayed on that 24% for, I don't know, 10 minutes. It took forever. It's still on the Apple logo. Let's see if it actually boots up or if it's still going to like give me a reboot. Swipe up to recover. Okay. I don't have power button plugged in, so let me just Press it once to turn the screen on. Here we go, swipe up to recover. Attempting data recovery, so let's let it go through the screen. Thank freaking God. I'm again very hopeful. I think we're in the clear now. So the NFC chip, the important one, the big one, is on the top board, and I never transferred the NFC chip in on this phone, so it's possible that the NFC mismatch was causing that issue. I'm not quite sure. Normally it wouldn't do that behavior. It would just go to the swipe up to recover screen. Maybe it's different on the 15 Pro. I don't know. A lot of iPhones will have the NFC chip on the bottom board, so you won't really see that issue with like a CPU swap. Anyways, I think we're probably going to be okay. Let's just wait for this to finish. It will take a few minutes, and then I'll be right back once it's done, and we can finish this out. Okay, so it looks like I'm in. Let me double check. It's having me go through the network settings for some reason, but it still asks for the passcode, so I know it has data on it. Anyways, it seems to be sitting on the screen for a little bit. I'm sure it's going to go through in just a moment, but I'm going to plug this into a computer as soon as it's ready. I'm going to pull all the photos from it and all the rest of the data as well. The customer's going to be very happy. This was quite a long video, and nothing even really went wrong. Just all parts of the process took a very long time. The fact that I didn't have a 15 Pro donor board already ready, like CPU removed, NAND removed, caused this to take a little bit longer. The fact that I didn't have the proper stencil for the RAM, that took quite a lot of time. And the fact that I had to harvest the RAM itself all took a lot of time. In the future now, I won't have to harvest RAM again. I already have a good one if I ever have to do a RAM swap on a 15 Pro again. And I already have a good donor CPU swap board as well. So once I'm done taking the data, I'll take the CPU off of this board so I can reuse this again. And, like I said, everything went fairly smoothly. Nothing really went wrong, just all the processes took a very long time. And just to recap, I do have the phone plugged into the computer now and it's taking data, and I kind of just want to go over everything that I noticed on this board. So the first thing that we saw was that it appeared to have a RAM short.
Alright, so I'll let you guys check out his final thoughts if you want to check out his video. But it kind of goes to show how profitable this type of repair can be and all of the things that go into it. Once you've invested the time and energy into understanding how to accomplish these types of things, and also the parts. And obviously you would have to invest in a donor board and all of the equipment that you need, but a lot of it goes down to practicing the actual techniques. That being said, once he's got the data, all of the money that he's poured into the donor boards and all the other parts really isn't consumed in the repair. So this $2,000 data recovery is actually majority profit, which is amazing for him, but also amazing for the customer, because there aren't that many people that can do this or that would spend, I am guessing, between filming and everything he's into just to repair itself, let alone the editing, whatever editing he's going to do, at least 8 hours, if not more. So, and other shops had worked on this, which makes the job even that much harder. You don't know exactly what they've done. You don't know all of the steps that they've done. So let me know your thoughts in the comments below. I know that this was a longer video, but it definitely wasn't 6 hours long. Yeah. There's a video that you'd like to recommend, leave it in the comments below. Thanks a ton for watching, and we'll see you in the next video.